Hi everyone, it's Kristen, and today I have a video for you on some topics that are going to be covered in your Practicum 1, and I just wanted to create this video to kind of give you an overview of what we've been covering in the review sessions before the Practicum over the weekend, and give you an idea of like what you might be asked to implement in your code. So let me give you a couple of examples of what I'm going to be doing. So the first thing I want to talk about today is declaring variables and doing typecasting and using input-output statements. So the first thing I'd like to point out to you is what I'm including at the top of my code. So over here, I am using an input-output stream library. This allows me to do cin and cout commands, which means computer in, computer out. And of course, it also allows me to use inlines and other things like that. I'm also using the namespace standard, which allows me to use all of the input-output stream library without having std::: attached to those operations, which is really handy when writing code. I'm also going to use the IO manipulation library, the input-output manipulation library, which allows me to do things such as set precision on the IO stream, such as when I'm doing a print statement. And lastly, I've got the string library as well, because I'm going to do a brief demonstration of how to use strings and characters. Just for reference, this is a comment block. We have a comment block here with a star, forward slash, and a star, and a star, and a forward slash, which allows us to leave as many comments as we want to in between this area. And just to point it out, if you're thinking about style, and indentation and things like that with your code, if you highlight a section of code, you can tab it in with the tab key. It will push it into the right, and you can use the shift tab to move it to the left, which is really handy when flipping code around and designing code, and it's just really good to know about. I have a main here with a lot of stuff that's commented out, but I'm going to kind of go through it in stages and kind of show you what you might be asked to do on the Practicum. So I'm going to start at the bottom here with some simple stuff. So the first thing I'd like to point out is how do we declare a variable inside of our main? Well, we can declare something like an integer. This is a integer type variable. The variable is called num, so that's the name that we've given the container, and it is of integer type, so it's going to hold whole real numbers, so 0, 1, 2, 3, all positive numbers, all negative numbers, but no floating point values. And here I'm doing the same thing, but I'm doing multiple variables at the same time. So I'm saying they're all integer types, and we're going to have a num1, num2, num3, num4, and we're going to catch these values from user-defined input. And we can do that in a couple of ways. In this section, what I'm doing is I'm asking for the values in succession. I'm saying, just go ahead and give me 4 values, one after the other, and I'm not really concerned about which one is which, right? But if you're concerned about ordering, or you want to be more specific with asking for user-defined input, you can match a cout with a cin for every variable that you want to ask for. So we ask for the value here, then we grab it. And the same with 2 and 3 and 4. And that's how we can basically get user-defined input in our code through cins and couts. Notice that couts point out of your code, like they're pointing out of your screen to be printed. And cin commands point in towards your variables, like num1, or in towards the code in general. It's a handy little tip to remind yourself of which way these operators are supposed to work. So I'd also like to talk about typecasting. So I'm going to comment out the rest of this and move down to another section. And talk about typecasting. So briefly, I just want to mention what typecasting is, in case you want to know and how to use this operation. Typecasting is when you take something of one data type, such as a floating point value. Here I have a double called val1, which is set to 5.7586, which is a 4 decimal floating point value. And I want to store it into an integer called output value. And I'm going to do that with a typecast, which allows me to say that when I set val1 equal to output val, and I put a typecast, which is the parentheses and the data type that you want assigned to the storage container information, what it does is it basically makes sure that what is stored in this variable is the correct output that you're looking for. So when we print output val, we're going to notice that what we get is the value of 5. Now I'm going to be using the g++ command to compile from my terminal, but you can also use the run button when you're working on your code. So the next thing I'd like to talk about is how to use setPrecision. So let's talk about using setPrecision on floating point values. So here I have a double numVal. It looks like it's a floating point to 6 decimal places. And what I'm going to do is use setPrecision on this variable when I print it to the user of the program. So here you can see that I'm printing the value before it is altered by setPrecision. So setPrecision will not work on it if you declare it above the line you want it to, but it will work on any other variables below it in the code, because it will continue to be fixed onto the output stream for any other variables, even if it is not just the output that you're looking for. So if I run this, let me make sure that I can. Yes, okay, everything's good. So what I'm going to do is I'm going to use my g++ command. And if you didn't know this, when you're using your D-pad, your bash will actually save your path directory, so you can use that to your advantage if you're compiling. And you can see here that what I'm getting before and after is the setPrecision working. So here we've concatenated the variable down with setPrecision to 2 decimal places in our output. And you can see here that we declare an output num value in these 2 lines of code. And then here we print using setPrecision and fixed before we print num value in this output statement. So we added in setPrecision, which is a function call because of the parentheses and the argument which it contains, and that 2 represents the number of decimal values that we want to be printed to the screen. The fixed allows it for every other variable in the output stream below it. And then we print the variable after the fact. This will allow the setPrecision to work on the variable. And that's why we get these 2 different outputs. Okay, so the next thing I'm going to talk about is basic string commands and character commands. So what are we talking about when we talk about characters and strings? Well, a character is anything that is actually on your keyboard. So if you have some kind of a symbol on your keyboard, that is a character, and it can be added into the code as an individual thing, just like a number. And a character also has an ASCII value, just like all of the letters of the alphabet and all of the different symbols on your keyboard. A character is stored using a char data type, which is a primitive data type, and we can see that because of the purpling of the colorization of this data type on my char, which is the variable. And we're storing a single character, the A, inside of the single quotations. So in order to store a character or to look for a character, you have to use single quotation marks, which is very important. And notice that if I tried to add in a letter like AB, it would not allow that. The data type would change color. And here, because I have included the string library, I can use a string called output, and I can assign it these characters. We're going to assign multiple characters. And if I wanted to leave output empty, output could be just left in double quotations. And that's the real big difference here, is that a character requires single quotations, and a string, since it's multiple characters, it's an array of characters, output requires double quotation marks. So I can just write as many characters in here as I want. I could write a giant amount of information in there if I wanted to. And that information can also be operated on just like any other integer or floating point value. It has similar arithmetic operations. So this is what we're talking about with arithmetic operations on strings with characters, is that output can equal itself, A, B, C, D, E, F, G, plus we can add a character here as an additional string. So we're passing an additional string and adding it to output, but it only contains one character, which is a space. And we're also going to add the value of the character stored within my char, the variable above, which is an A. So when we run this code and we print output, what's going to happen is that we're going to see that we've added onto what was originally stored in output. And you can see that we have that space and that A added on to our string. Okay, so the next thing I want to talk about is basic if-else conditional statements and how that works, and also about modulus operations to evaluate arguments based on even and odd values. So in this part of the code, notice that I have declared this value called numValue, and I've set it to the value of 101. And what I'm doing here is I am checking to see if 101 is even or odd using conditional statements called if-else logic. You can see here that in my code I am using the if command, which allows for a parenthetical argument, and inside of the argument I'm taking the variable called numVal, and I am using the modulus operation on it with the value of 2. So this is me taking numVal and comparing it and saying, is that comparison equal to the value of 0? So I'm saying, okay, when I take numVal and divide it by 2, will I get a remainder of 0? And does that mean, is that, if I get a remainder of 0 when I divide something by 2, it should divide evenly. So it should be an even number. But if it divides oddly, then you're going to have an odd number, which means that when you modulus something by 2, it would be 1. So in conditional Boolean logic, we say, okay, if this is true, if this whole statement here evaluates to true inside of our parentheses here, then we will go into the scope of this if statement and we will print our cout statement. Otherwise, if this if statement evaluates to false, then what happens is this code gets jumped over and our else statement takes over and we evaluate another secondary operation. And here we would print this as the alternative if our if statement failed. So it's like the reverse logic. If this is not true, then do this, basically, is the logic that we have here. So let's see what happens when we evaluate 101. So realistically, if we evaluate this argument, right, 101 divided by 2 is not going to be 0 because it is an odd number. So I'm guessing that what's going to happen is that we're going to go into our else block and print the alternative value. Let's check it. So we can see here that we've gotten an odd value, and that's because when we evaluated 101 divided by 2, we did not get 0. So because of that, this logic failed and we went into our else block and printed the value that was odd. If we change this to 0 and we got 100, we could divide this and get the value of even when we print the screen. And we can see that like this. The next thing I'm going to talk about is how to structure your code. Let's see here. So the next thing I'm going to show you is how do we talk about structures of code. Okay, so I want to point out that if you're creating complex if statements, the best way to do it is going to be doing the following type of code. We can set up our code using an if conditional argument in parentheses, And for the moment, since you're just learning about scope operations, I would highly suggest dropping your brackets so that you can really see what's going on with your code. This allows you to, one, align your code. You'll notice that when I highlight one bracket, it's going to connect to another, so you'll know where a code conditional operation starts and stops by its scope operators. And likewise, as below, we notice that we're chaining these onto each other by stacking them together in our code. And in this logic, the way you want to think about it is that we have an if statement that gets evaluated first. If this is true, then we'll go in here and do something. Now, if that is false, then we would evaluate this argument instead. So if our if is false, then we will go into our else if. If the else if is true, we'll go into the else if and do something here, right, as an alternative to the if. But if else if here is false, then we will have to go down to another else if and check for a third check and see if something else is true. And if this is false, then we will go down and check for something called an else. And an else is saying if we have any arguments above, like chained together, like if and else of, what it says is this is the exception to that, and if all else fails, if all these other cases fail, do this other operation here. So the next thing I'm going to talk about briefly is indentation. So in C++, it's really important, and it's really important in any language that you work with in the future, to have really good indentation so that you know where your code starts and stops with its conditional operations. So let's take a look at this. From a glance, you can notice that these are nested if-else statements, right? And you might also notice that there are lines that connect these pieces from our top to our bottom here. So when we nest our if-else statements like this, we can easily read our code and figure out that this would be within this argument, and that those two arguments that are here would be within this larger argument here, which would be followed by a smaller argument here with another smaller argument inside of it. So this is a way of like basically putting together a code skeleton before you actually design what's going to be the argument within it. So let's talk about complex conditional arguments for a second. So say we're doing two things, right? We can say, all right, if we have two Boolean variables called value1 and value2, Boolean variables being something that's either true or false or 0 or 1, we can say, like, is this operation here, operation A, true? And using the double ampersands, we can evaluate to see if this operation with value 2 is also happens to be true, meaning that they both contain the value of false. And they both have to contain the value of false in order for this entire if statement to be true. If and only if do both variables contain the same variable that we're looking for, will we print this statement. Otherwise, we will always print this statement instead as the reverse of that logic. So now that we've covered if-else logic, I think that we should talk a little bit about taking that logic a step further. One way we can do this with an if statement is if you want to do very specific argument operations, you can do that with parentheses. And this might be really useful in your code moving forward, is to evaluate the first thing you're looking for on this side of the and with parentheses, and the second thing on the other side of the value of the and sign with parentheses as well, saying that this is condition A and condition B, and they both have to be true in order for this to happen. Since we talked about if statements a lot, I'm going to switch over to switch statements, and I'm going to talk about those. And specifically, I want to talk about integer switch cases, and also character switch cases and why they're different. Switch cases are incredibly powerful. They're really good for using for menus or for multiple different values that are stored in succession to be printed or operated on. And in this case, what we have is we're using an integer called the switch value. We're going to set it to 0 by default just to initialize it. And then we're going to actually grab a value from the user, and we're going to use that in our switch operation. So the first thing we do is we switch on a value. So when we do that, what we're doing is we're saying switch into a case based on the stored value within this variable. So here we have a case, and we know that it's looking for the value of 1. So if switch val has the value of 1 from the user, we go into case 1, we print this operation. Normally cases will always contain a break in them, and in this case what we're doing is we're basically having individual breaks to create scope-specific commands. So in case 1, if we enter it, we're going to print something and then break out of the function and continue down out of the switch statement. If we run the code and we did not have a break statement here, we could go to case 1, print this operation because this was true and the value was 1, and then go directly into case 2 and print the value of 2 because there is nothing stopping us with a break statement from entering this other case below it. So if you're looking for printing multiple cases in succession, you could take out the values for the break using the comment code, and if you entered 1 or 2 or 3 cases, so if the value was 1, 2, or 3, in this scenario, because we don't have breaks in 1 or 2, it would always print 1, 2, or 3 depending on what we printed. So we could print 1, 2, 3 for 1, or 2, 3 for 2, or just the value of 3 into this case. Notice case 4 would not print because we have a break already in case 3. If we have any value that is entered that is not in the specified cases above, the default case takes over. So for any value out of the range of the cases already listed, so we have cases between 1 and 4, so if the value is anything other than those cases listed, it will be going straight to the default case and asking maybe for some more user-defined input, or you can just say that that was invalid. So this is how an integer-based switch works, and I'm next going to talk about what happens with character-based switch cases and how that works. So in this example, we have a character called the switch val. So we had the same variable, but we renamed it as a character data type. And we asked for the same variable. And we're going to switch on the same variable now that it's a character. And we're looking at, based on the character stored in switch val, we're going to switch into the case labeled character A, character B, character C, or character D instead of 1, 2, 3, or 4. We're still going to have our default. So if we don't have any characters that are listed that are not these 4, it's going to go into the invalid case character section of the default and print that information. So same as before, they work exactly the same way. So you do want to have break statements, but if you want to print all of them in succession, if you were to put switch val in as a case A, and switch val had the value of A, we would go into case A, print case A, then print case B, then print case C, through to case D, and even our default would still print as well because we don't have anything stopping our case D from going into our default once we're in our switch statement. Switch statements are incredibly powerful, and they're great for menu design and also for handling a lot of different data values that you're looking for in a range. And with that, guys, I think I'm going to wrap up the things that you might be quizzed on. I hope this video was helpful and informative, and likewise, I hope that you have a good practicum. Best of luck.